Hi everyone. So in this lesson, we're going to be doing 1.3. So that's Unit 1, Lesson 3, Solving Linear Systems by Substitution. So this is another way that you can find the either one solution, no solution, or infinite solutions to a linear system. So you can do that by graphing, which we did last time. Sometimes, though, you might not have a graph that's most available. Drawing a graph can be kind of tedious and annoying. So this is another way that you can do it. Okay, so we're going to be covering what substitution is and how to solve a problem this way. So by the end of the lesson, you should be able to solve a linear system by substitution. You should know how to check your solution, although this is the same as it was with graphing, and identify cases where there are infinite solutions or no solutions, because you aren't going to see graphs of these lines. So how are you going to know if there are infinite solutions or no solutions? Okay. So to understand substitution, I'm going to go to a movie that I quite like, old movie, The Godfather. So there's something that happens in this movie. Okay, so mafia boss Michael Corleone is warned by his father, the Godfather, that whoever approaches him with an offer to set up a peace summit between the families is a traitor. So they know there's a traitor, and he realizes that the person who wants to set up this peace summit, there's not going to be any peace. Michael's going to be killed. So this person is the traitor. And Tessio offers to set up a peace summit. So what can Michael conclude about Tessio? This should be a pretty easy problem to solve, right? If the person looking to set up the peace summit is the traitor, and Tessio offers to set up the peace summit, right, then Michael can conclude that Tessio is the traitor. Yeah, good things don't happen to Tessio. But that's the basic principle behind substitution. If you have a statement like 1 and a statement like 2, then you know that this third thing is true. Okay, so if we put it into more math terms, if peace summit organizer equals traitor and peace summit organizer equals Tessio, then we can conclude that definitely Tessio is the traitor, right? So the more general way of saying that is if A equals B and B equals C, so A is the same as B and B is the same as C, then we also know that A is the same as C. So this is how substitution is going to work. Okay, let's apply that to a linear system. You have y equals to 2x plus 1, and you have y equals to 5x minus 8, right? So we know that y is equal to this, and we know that y is equal to that. So we can therefore conclude that this part here is equal to this part there, right? A equals to C. This is equal to that. And so we substitute y from one of these equations, and it doesn't matter which one. You can pick one or pick two. We'll pick one. You can substitute y with the other thing that y is, 5x minus 8. So we just put 5x minus 8 there. So we get 2x plus 1 equals 5x minus 8. And that's really useful to us because now we have an equation that only has one variable, right? We don't have any y's anymore, we just have x's. And that means we can use algebra to solve it. Okay, so 2x plus 1 equals 5x minus 8. So I'm just going to bring the 2x over to the right side, and it becomes a negative 2x. I'm going to bring the 8 over to the left side, so it's negative 8 on the right side, so it becomes positive 8 on the left. And then that's really easy to solve, right? 1 plus 8 is 9. 5x minus 2x is 3x. Divide both sides by 3, and we get x is equal to 3. Okay, so by using substitution, we are able to find out one of the two variables. So we found out x. We found that x is equal to 3. But we're not done yet because remember that a linear system, the solution to a linear system gives you an x and a y. So we also have to find a y. But now it's really easy because if you know what x is, you can just substitute 3 for x in either one of these equations. Again, it doesn't really matter which one. Okay, so I'm going to put 3 into the first equation here. So 2x plus 1, y equals 2x plus 1. I put 3 in there, and I get y equals to 7. Okay, so now I have my answer. It's 3 comma 7, or in other words, x equals 3 and y equals 7. So you can check your work in much the same way that I did in the graphing lesson, right? The lesson before this one. Do a left side, right side check on both equations, and you'll find that it works out. But if you want a quick way to check it that's a little bit more informal, easy way to do it, we know that x equals 3, or at least we think we do. Just plug 3 into both equations. Do you get the same answer both times? If it's right, you should. So I know that if I plug 3 into here, 2 times 3 plus 1 equals 7. So, okay, so if 3 goes into this equation, y equals 7. What if I put 3 into the other equation? 5 times 3 minus 8. 5 times 3 is 15. 15 minus 8 is 7. So yeah, it works, right? If I put 3 into this equation or 3 into that equation, I get the same y. And that's what the solution to a linear system is, right? That the same x value in one equation, in both equations, will give you the same y value. So 3, 7 is our answer. Okay, it does get a little bit more complicated when we look at example 2, because you don't have y equals something, right? You have more complicated arrangements, and so you can't just substitute what y is into another equation. So how do we do substitution in this case? Well, what you got to do is take one of these equations and figure out what either x is or what y is. And the way I would do that is I would just do whatever is easier. And if you look at the equation, you can kind of figure that one out. So if I'm looking at the equation here, the second equation, I notice they're all even numbers, so I can divide them all by 2. I also notice that the x has a 2 next to it. So that means I can get rid of this 2, and since these numbers can be divided by 2, I won't get any fractions. So that's kind of nice. If I just take this whole thing and divide by 2, I can isolate for x without any complicated fractions. So I'm going to do that. 2x plus 4y equals 8. I'll bring over the 4y. 2x equals 8 minus 4y. Divide everything by 2, and I get x equals to 4 minus 2y. So I now know what x is. X is this. So this can then replace x in the other equation that I didn't use. So I used the second equation. So I'm now going to take this 4 minus 2y, which is the same as x. Since this thing is the same as x, it can replace or substitute x in the first equation. So that's what we're going to do. I write the first equation here. I then take what x is equal to, and I replace x with it. Remember that everything has to go in brackets, because if you don't do that, you're not going to distribute correctly. This 3 has to distribute to the 4 to give you 12, but it also has to distribute to the negative 2y to give you negative 6y. So the 7y is not part of that, so that remains behind. And now I just do some algebra. So negative 6y plus 7y, that goes away and becomes just y. I bring the 12 over to the other side, and it becomes a negative 12, and I get y equals to negative 8. Okay, so I found one of my two variables. All right, now I've got to find the other one. So y equals to negative 8. I'm going to put negative 8 into either one of these equations to figure out what x is. So I'm going to put it into the second equation. 2x plus 4 times negative 8 equals 8. Again, I've replaced y with negative 8. 2x minus 32 equals 8. Bring over the negative 32, so that gives you 40. Divide both sides by 2, x equals 20. So we have 20 and negative 8, so 20 comma negative 8 is our solution, or in other words, x is 20, y is negative 8. Okay, I did a left side, right side check here, but again, if you want to do it informally and a little bit faster, just take negative 8 and put it into the other equation and see if it works. So I would put negative 8 in there, and that will give me negative 56. I bring that over to this side, 4 plus 56, right? The sign will change to give me 60. Divide by 3, and yes, I end up getting the same answer of x equals 20. So it works. Okay, so we're going to look at example 3 here. We said that you can also have infinite solutions or no solutions when you have a linear system. When you do substitution, when you have one solution, it's pretty easy. You get a y, you get an x, and that's it. That's your answer. But what does it look like if you have infinite solutions? Okay, well, here we have an example of two equations that are going to give us infinite solutions. These are actually both the same line. But again, they don't necessarily look like they're the same line. So I'm going to do the same thing. I'm going to isolate one of the variables here. So I notice that my first equation is simpler, and everything can be divided by 4. So again, that means I can isolate x and not get any fractions. So that's what I'm going to do. I bring over the 8 on this side. X equals 4 minus 2y. Right? I've divided everything by 4 to get rid of this 4. Okay, so if I know that that's what x is, I can then take my other equation and replace x with 4 minus 2y. So that's what I'm going to do here. There's my other equation, and I've taken x and I've replaced it with 4 minus 2y, remembering to distribute. I do some algebra here, so 12 times 4 and 12 times negative 2y. And what I notice is I have negative 24y and I have positive 24y. Those subtract and eliminate, and you're left with 0. So you end up with 0 equals 0. What does that mean? Well, 0 always equals 0. That's always true. In other words, it doesn't matter what x or y are, the two sides will always be the same. Or in other words, you have an infinite number of solutions. So if you get 0 equals 0 at the end of your substitution process, that means you have infinite solutions. And if you want, you can go back, put these lines into y equals mx plus b form. You will find that they are the same line. Okay, but what if you have no solutions? So here I've given you two lines that are parallel. They have no solutions. You're going to see that you get something similar happening. So same thing, I'm going to take one of these two lines and isolate for one of the variables. I'm going to isolate for x because, again, that's easier. Everything here can be divided by 2. 2x equals 10 minus 4y. So I'm just rearranging this first equation, and I get x equals 5 minus 2y, right? Divided everything by 2. Okay, so I then take this x and replace the x in the other equation with 5 minus 2y. And once I do that, I end up with a very similar situation. I get a negative 16 and a positive 16y. So those eliminate, and you end up with no y term. But what's different is on the right side, I don't end up with 0. I end up with negative 30. So I get 0 equals to something that's not 0. And what does that mean? Well, that's not true, right? 0 does not equal to negative 30. So if you end up with a situation where you get 0 equal to something that's not 0, then what you have is a statement that is never true, right? It's never true that 0 equals to negative 30. So in other words, it doesn't matter what x and y are, you are never going to have 0 equal to negative 30. This can never happen. So you do not have a solution. So this means that the two lines are parallel, but they're not the same line. Okay, so that's basically it. It's a little bit quick when I'm going over it this way. I don't like the fact that I'm not really drawing on something here. So if you want to see another worked example where somebody is actually writing down the actual numbers as they're going through it, please watch this YouTube video here. Okay, so again, reviewing what we've covered here, you should be able to solve a linear system by substitution, check your solution, and identify cases where there are infinite solutions or no solutions. So again, if you get 0 equal to something that's not 0, then you have the no solution case. If you get 0 equals 0, you have the infinite solution case. And if you get x equals something and y equals something, then you have the one solution case, and you can say what your one solution is. All right, that's it. Thank you.